Okay, so this PowerPoint is going to talk about the different types of heat and how they are a form of energy. Heat transfer. Heat is kinetic energy. Kinetic energy, we know from previous lessons, it moves in a couple of different ways. The energy moves. Heat is just one of them, but heat itself can move in 3 different ways. In all 3 of those waves, the movement of heat goes from the warmer object into a colder one. The first way that heat can move is conduction. Conduction is the bumping of molecules that moves heat through matter. Now, with conduction, heat moves by direct contact or by touching. So, if you look at the images, those are both pots on the stove. For conduction to take place, it has to touch. Something else you need to realize is that conduction is how heat moves through solids and only through solids. There are 2 different kinds of matter when dealing with conduction. For starters, we have on the left side, let's look at this first, we have conductors right here. A conductor is any object that transfers or moves heat quickly, then it's considered to be a conductor. You also should realize that a good conductor is going to be a poor insulator. So metals make excellent conductors. Copper, silver, and aluminum are examples of conductors. You do need to know this right here, that good conductors are poor insulators. The opposite of that is an insulator. If an object traps the heat and it won't let it out, then it is considered to be an insulator. And of course, the opposite of a conductor, a good insulator, is a poor conductor. So look at glass, wood, sand, and air. Those are all examples of insulators. Okay, so SOL test prep question number 1. This information is on your paper. I want you to simply circle the answer that you believe is correct, and then when we get to the end, we'll determine if the answer you have right here, whether or not it's true, if you have the correct answer. So the question is, what is the name of something that can reduce the heat flow between 2 materials? Is it A, an insulator? Is it B, is it A, an isolator, B, an insulator? Oh no, that's supposed to say C. Or is it D? Is it C or is it D? We're just going to pretend that that mistake is not there. The second type of heat transfer is convection. In convection, the transfer of heat will move within gases or liquids, and again, it is from warmer to cooler. And an example of convection is when heat rises. Okay, so think about if you live in a 2-story house or a townhouse, that your upstairs is usually always warmer than your downstairs, and that's because heat loves to rise. It likes to be upstairs, it likes to go to the higher temperature, and with that, we're going to find that convection is only seen in liquids and in gases. So you will not see convection take place in a solid. Convection currents is where warm air rises to the top and cold air is pushed down. Okay, so look right here. You see how this is a cycle. It's a cyclic current that you are able to witness. This is why the downstairs is colder than the upstairs, and that's, like I just said, heat rises. Thunderstorms form due to warm air rising and cold air falling. So right here you've got the air going up, down here is the cold air coming down, and that makes a convection current. The third type of heat transfer is radiation. Okay, radiation is energy that can move through a vacuum. What is a vacuum? Well, a vacuum is just empty space. And heat is going to move through that vacuum in the form of infrared rays. We haven't talked about what infrared rays are, but we will go into that when we discuss the electromagnetic spectrum at a later date. All you need to know right now that radiation, an example of that is the sun. The heat from the sun gets to us by radiation. This is because there's not enough molecules to get to the earth by conduction. Obviously, that would be bad if the sun touched the earth, or convection, if there were a transfer from higher, if there were a transfer of the heat rising. That would be a bad thing because basically we'd be way too close and, the earth would boil. And that would be a bad day. So heat rays do not need molecules in order to move from one place to another. They're able to travel through that empty space. An example of radiation is seen in the pictures here. And what you need to realize is that radiation sends out heat in all directions. Everything warm sends out heat by radiation. So in this example right here, looking at this picture of a fireplace, you see that the air is, no matter where you were to stand, you would see the heat coming out. And no matter where you are, if you're in the sunlight, if you're at the beach, it's going to project the sun rays, and it's going to either A, give you a sunburn, or B, just make you feel really warm. So you've got heat from the sun, heat from a light bulb, and heat from a fire. Those are some examples. So how are all three of these different? Well, the biggest one is in conduction, the objects must touch. In convection, liquids and gases, they have to move. And in radiation, heat travels through space in waves. I would like for you at this point to put a star here because you really need to know this information for your next quiz. Okay? If you look at this picture here, you will see that just like we've seen in the textbook example, in this one situation, you can have all three heat transfers. You've got conduction in the person holding the pot. You have convection, the currents are going on inside of the pot. And then radiation is the heat coming out of the fire. So question number 2. Again, we're going to ignore the fact that this program did not accept that was A, B, C, and D. So the Earth is warmed by solar energy. How is energy transferred from the sun to Earth? Is it A, radiation, B, convection, C, conduction, or D, ultrasonic? SOL test prep question number 3. Convection is the result of A, currents caused by the motion of heated molecules, B, increases in the density of solids, C, colder portions of liquids rising, or D, the lack of heat transfer. We've now discussed the different types of heat transfer. What I want to review with you at this point are heat and phase changes. We've talked about phase changes before. You may or may not remember them. Melting point, boiling point, freezing point. So we're going to go into a little bit more detail now. You need to understand, in case you have forgotten, a phase change is a physical change that requires a change in heat energy, and it is the addition or the removal of heat. This right here is a phase change diagram. If you need to, you're going to be pause this as needed, but you will need to write in the information here so that you understand that going from a solid to a liquid is melting. Going from a liquid to a solid is freezing. From a liquid to a gas is vaporization. From a gas to a liquid is condensation. From gas to solid is deposition. And from a solid to a gas is sublimation. This point right there is called the triple point. Okay, test prep question number 4. Please use the diagram on your paper and not this one here, because the program that I'm using to record this, it for whatever reason did not actually include the information. This picture is not the way it's supposed to be, but if you look at your picture, then you will see the arrows that are present. So I want you to tell me the proper labels for arrows A and B. Again, look at your paper and try to determine this answer. Is it A, boiling? Is it, and B is freezing? Is it A, evaporation, and B is precipitation? Is it C, A is sublimation, and B is deposition? Or is it D, A is gasification, and D is solidification? And again, same situation for test prep question number 5. You are not going to use that chart. You're going to use the image that is on your own paper because it's the one that is correct. This image did not come across properly. I want you now to identify what arrows C and D are using the choices here. Is C precipitation and D solidification? Is letter choice B, is C condensation and D freezing? Is it C evaporation and D sublimation? Or is it D, C is boiling and D is deposition? And I spelled that incorrectly, but you get the gist. So here is the phase change diagram one more time, just to point out a couple of things. As temperature increases, pressure increases. You have your triple point. You have what's called a critical point up here. And this I wanted you to see for purposes of color, the way the chart breaks, because you might see something like that in the future on the SOL test. Okay, so let's get to the point. What's the purpose of a phase change diagram? Well, for starters, it's to point out what the freezing point is. This is review from when we were talking earlier in quarter 1, and I know quarter 1 was so long ago that we don't remember anything, so we're just going to go ahead and review it one more time. Freezing point is where a substance freezes into a solid from a liquid. Okay, so you're going from liquid to solid. Ice, you're going from water to ice cube. All right, melting point is where something melts and you go from a solid to a liquid, so that ice cube has turned back into water. The boiling point, which is aka the heat of vaporization, that's the temperature where liquid becomes a vapor and then it becomes a gas. Okay, so you've got water that you're trying to make some macaroni or some oodles and noodles, and you've got it on the stove. It's no longer liquid, it's now boiling and turning into steam. Okay, so let's go over these answers for the test questions that are on your paper. So go ahead and flip back and find test question number 1, and let's see if you got it correct. Test question number 1, which is the name of something that can reduce the heat flow between two materials? The answer is actually B, it was an insulator. Test question number 2. The answer of how the Earth is warmed by solar energy, the answer was A, radiation, because it's going through a vacuum. Test question number 3. Convection is the result of currents caused by the motion of heated molecules. Test question number 4. The answer was A. Letter A was the boiling point, and letter B, the freezing. Test question number 5. The answer is B. Letter C is condensation, and letter D is freezing.